VIDVAS Learning is a product of VIDVAS Technologies Private Limited. In this session, we would go over LTE Intra MME Intra SGW S1 Handover Direct Forwarding Call Flow. The following is the list of widely used abbreviations in LTE EPC. The diagram shows non-roaming architecture for 3GPP access. We assume that you have fair understanding of LTE EPC architecture. If not, please go over VIDVAS Learning LTE EPC Overview video tutorial. Let us go over LTE Intra MME Intra SGW S1 Handover Direct Forwarding Call Flow. Assume UE is attached in LTE network. There is no indirect data forwarding tunnel between source ENB and SGW, in this call flow. UE sends RRC measurement report to ENB. Based on the signal strength received in the measurement report, source ENB decides to hand over the UE to target ENB. Assume X2 connection is not available from source ENB to target ENB. X2U channel may optionally available. Source ENB sends S1 AP handover required message to MME. MME sends S1 AP handover request message to target ENB. Target ENB sets up the radio bearers and sends S1 AP handover request acknowledge message to MME with target ENB FTE ID for downlink path. MME sends S1 AP handover command to source ENB. Source ENB sends RRC connection reconfiguration message to UE, indicating to camp onto target ENB. S1 AP ENB status transfer is sent by source ENB to MME, only if at least one RLC-AM bearer is accepted by the target ENB. If all bearers are RLC-UM, S1 AP ENB status message will not be sent. MME sends S1 AP MME status transfer to target ENB. If there is any uplink data or downlink data received at source ENB from the UE, or for the UE, source ENB forwards the data to target ENB, by sending X2U data forwarding message. This is because handover is in progress. Target ENB takes responsibility of sending the UE data. Target ENB may buffer the data received from source ENB, until it receives RRC connection reconfiguration complete message from the UE. After receiving RRC connection reconfiguration complete from UE, target ENB forwards buffered downlink data to UE, and forwards buffered uplink data to Internet via SGW and PGW. Target ENB sends S1 AP handover notified to MME. MME sends S11 modify bearer request to SGW, with target ENB FTE ID for downlink path. SGW sends S11 modify bearer response to MME. Beyond this point, any downlink data received at SGW from PGW will be sent to target ENB. SGW sends S1 UN marker to source ENB. This is to inform source ENB that handover is complete, and source ENB does not need to forward data to target ENB anymore. Source ENB sends X2 UN marker to target ENB, to inform target ENB that target ENB can discard any packet that it may receive from source ENB on X2U interface. MME sends S1 AP UE context release command to source ENB, to clean up the UE context. Source ENB sends S1 AP UE context release complete message to MME. The following is the list of 3GPP references. 3GPP 23.401 for LTE architecture. 3GPP 33.401 for security. 3GPP 24.301 for NAS. 3GPP 36.413 for S1 AP. 3GPP 36.423 for X2 AP. 3GPP 29.272 for S6A. 3GPP 29.274 for GTPC. 3GPP 29.281 for GTPU. 3GPP 29.212 for GX. 3GPP 32.299 for GNGZ. For upcoming videos, please subscribe to VIDVAS Learning channel at the following location. For any queries, please contact us at vidvaslearning@gmail.com. To know more about VIDVAS Technologies Private Limited, please visit our website www.vidvas.com. Thank you for watching.